Okay, in this video I'm going to talk about the different elements that make up an electric circuit. So we're going to talk about batteries or power supplies, wires, switches, and loads. A battery is the thing that makes electrons want to move around the circuit. It creates that area that's positive and that area that's negative, where the electrons want to go from the negative area to the positive area. In our little description that I used here, right, so as I've shown in previous videos, a battery makes a negative region in a positive region where the electrons want to get from the negative to the positive region. The strength of, or the amount of charge in these regions, is described by the voltage of the battery. A battery in a circuit diagram is given this symbol, where the long side is the positive part, so this would be the long side, and the short side is the negative part. Wires provide a low resistance path for electrons to flow. So if we imagine here again in our electric circuit, if we have our pathway from one to the other, that's our wire. And in an electric circuit, we simply represent them by a line showing where the electrons can flow with hopefully low resistance, but really we treat it as if it's no resistance. A switch is used to open and close the circuit. So we can almost imagine it like a drawbridge, where when it's open, no current can flow from one to the other, and then we can close it to allow the current to flow. So this can swing open or shut. And for an open switch, we draw it like that. That's open. And for a closed switch, we draw it like that. Switches are used so that these electrons won't flow all the time, and we won't waste all of the energy of the battery. Finally, the electric load. If we have our electrons flowing from one region to the other region, we want to make sure that there's a specific spot in the circuit where the electrical energy, or the buildup of electrons, can be used to convert the electrical energy associated with the electrons into whatever form of energy we want. Electrical loads are represented by symbols that try and tell us what kind of electrical load it is. So that would be a light bulb. If we had a motor, we'd put an M in the middle, and there's lots and lots of symbols that are used for different loads. So this is what's really going on in this circuit, but if I wanted to make a schematic of this circuit, I would have the wire come out of the battery. Here I would have an electrical load, something like a light bulb, and then it would flow to, right now as I have it drawn, a closed switch, and back to the other end of the battery. This would be like 0.1 on the circuit. This would be like 0.2 on the circuit. This would be like 0.3 on the circuit. And these wires, and this switch, which again, remember this can swing open, would be like 0.4 on the circuit. So we use these kinds of schematic diagrams to show the electric circuit, and we show it as a complete circuit where we connect these guys back, recognizing that to create this deficit and this excess of electron, the battery will sit here taking electrons from one side and placing them on the other. So that's what an electrical circuit is doing, and that's why it works the way that it is, and that's how we draw it when we want to communicate with other scientists.